Hey guys, 6 in the morning. We're going to learn about some structs today. So structs, if you use TypeScript, this is going to be a very just streamlined thing to understand and learn. Those who have not learned TypeScript, let's learn about it. Let's learn about it together. Basically, the idea from a bird's eye view is structs define the data shape. So if we want to build a thing of data for a to-do list, right? Let's think about what that is. A to-do list is a list of to-dos. Now, look at the smallest thing of a to-do list, which would be the to-do. You have a title, to-do title. You have an ID with the to-do. Is it the first to-do? Is it the second to-do? Is it the third one? Is it completed? You can add other data structures like that to a to-do. So when building a struct, they can feel complicated, but don't look at it through a complicated lens. Try to look at it as, I'm just defining the data associated with this thing. Okay, so let's read about it. With structs, we can create custom types in Solidity that are essentially groupings of variables. For instance, we have an enum of directions, so we can choose up, down, left, right. Guys, I'm gonna turn off the AC real quick. Forgive me, I realized that was on. I was wondering why it was so chilly. Okay, so we have a struct of a hero, directions, which are that enum of up, down, left, right. We have uint health, so some numerical value for health, and a true false value for in air. Not sure what in air is trying to define, but some sort of Boolean value. With the struct, we can create new heroes which contain just these three properties. We can create a new hero by invoking the struct with the parentheses. So something like this, and then pass in the data that we want here. So this hero is facing upwards with 100 health, and true is in air. We can then use the dot operator to retrieve the values from the hero in the future. So if we want to use this hero, we can say hero.health, and it should return the health value, which is the second one. If we do hero.inAir, we get the true value, or hero.facing, we get the facing value that we passed in, which is up. Well, he compares it to directions.up, so therefore it returns true. I feel like there could be a better way to show structs here. So we'll say struct to do. Again, I think this is just a good starter package. So I'll say string for the second thing. The first one is just the to-do ID. Most objects and structs that you build may have an ID associated with them. String will say to-do text, right? So we'll keep it as simple as this. And then if I want to build this to-do, I could say to-do, just to define the to-do is why I'm prefixing it with the to-do equals to-do. And I need to pass these things in. So I'll say the ID 1 and the string will be the first to-do. So if I want to access to-do ID, if I console log this, I'm not sure if we have the console log available with Solidity, but this would equal 1. And if I console log, you guessed it, to-do text, we should get the return value of this first to-do. So how it works is the structs are just structures of data. We can define the structure of data, break down every bit of things that we need for the structures of data. So let's dive into what they've asked us to do. I'm going to move my face. Create a new struct called vote that contains two properties. A choice is choice. So let's do the initial part. Struct vote. A choice is choice, and an address voter. You can see they've defined choices for us up here. They have not defined the address voter. This will be the wallet address for the voter of this person. Looks like we're potentially building some sort of voting smart contract. Okay, so that was first step. The second step, then create a public storage called vote, which is of the vote type. Let's do our best at this. I'll say vote. And I suppose I could do public here. Vote, public, vote. Finally, in the create vote function, create a new instance of vote and store it in the storage variable vote. Use choice. Okay, 1 bit. Let's do 1 bit at a time. So finally, in the create vote function, create a new instance of the vote and store it. Let's say vote. Store it in a storage variable called vote. Okay. Do we need to prefix this with storage here? Is that what they're prepending here? Let's see. Storage variable called vote. A little tied up on that one. Okay, use the choice passed in as the argument and the message.sender. So the choice is being passed in here. So we can pass that into the vote, the first one, and the msg.sender for the second bit of our vote, which will be the voter. Let's try. Vote, message, sender. Interesting. I believe I have this backwards. Let's try this. If we say storage, vote, goes this. Okay, let's take a peek, see? The contract.sol. Let's see. So here's what we have on the left. We've done the struct correctly. We've instantiated the vote variable correctly. And the second one, we were almost there. It was just vote assigned to the vote variable. So what was the deal with the storage variable? We didn't need to define it as storage. I think they were just saying make a variable. Great. Okay, so we had to wrestle with that a bit, but the biggest thing with structs is identifying that they are molding the data for us, and we can then add to that mold, say, okay, this vote is with this piece of data and this piece of data. That's what makes up that vote. Moving on, returning structs. When you're returning structs or other reference types like arrays, you have to clarify where the data is coming from using data location keywords, storage, memory, or call data. However, for external and public methods, you can't use the storage keyword for the return parameter. The storage keyword would provide a direct reference to a location within the contract's own persistent storage. Storage, I believe, is more expensive than memory and call data. Okay, storage which can not be accessed outside of the contract, use memory or call data instead to return a copy of the data. Storage is creating a new memory instance of data. Memory and call data create copies of the data. So if we use storage, we're going to overwrite values within the contract. Memory will copy the value, and we can mess with the copy of the value, but not the actual value. So let's take an example, or let's take a look at an example of a struct being returned in memory. So here's their struct. It's just a simple hero with one parameter of health. Function post the hero, just pass in the health. So they're taking the hero.health value and console logging it, returning 100. From this one is returning hero 100. This is the one we want to focus on, the hero memory, returning the struct hero with memory. I will move my face. Our goal is to return memory vote, create an external view function called create vote, which takes choices, which takes choices value as a parameter and returns an instance of type vote. Okay, let's build this create vote function. Function creates vote. Say external view returns. This is where it's going to get a little bit cheeky. So vote memory. Let's reread that one more time, which takes choices value as a parameter. We need to pass that in. So choices here. I'll prepend it with the choices term, and to declare it's a variable, I'm going to give it the underscore with it. This function should use the choices value and then the message sender as the values to create a vote. What we need to pass in then is going to be choices. The very first thing we need to do, pass in for the choice. I suppose this could be underscore choice, assuming it's just one choice being passed in. And the voter will be the message.sender. Believe we could just return that. Let's see. We cannot. Why is that? Why can we not return that? I feel that is precisely what they're doing on line 8 through 11 here in the example. Return hero. Passing in the hero value. Let's see. Forgive me. I was returning choices, not vote. That was my fault. That was my fault. Great work, my fellow scientists. They're scooping us up here. They're scooping us up with the energy. Okay, perfect. So, when we want to return a struct, we need to use call data or memory. Let's play around with the call data. Let's see if that'll work. No, it will not. Not for this example. I always love to do that. I love to break stuff, test stuff, see what's going to break. See, it just expands my knowledge a little bit. So you'll see me do that. Struct arrays. We can create an array of struct types just like we would with any other data type. Here's an array of numbers. We also have an account where we could do a struct of an account. Perfect. So that would be very similar to our list of to-dos. If our struct of a to-do was uint ID string to do text. We could say a list of to-dos would be an array of this. So to do, boom, with that square brackets. Okay, let's see what we need to do. We can also push and retrieve accounts like any other storage array. So accounts.push, push an account in there with the ID of 0, balance of 100. And we can access the accounts at the 0th position, ID 0. Great. I'm going to move my face. Of course, push only works on storage arrays as we learned in the lesson of arrays. Okay. Create a public storage array of the vote struct called votes. Okay, let's do this. Create a public variable. So we'll say vote, public votes. Vote with the vote with the brackets is saying we can take a list of votes. The type of these things will be repeated a bunch of these. That's the bracket vote here. Okay, so create a vote to do. Add a new vote to the array of vote state variable. Let's read a little bit more about this. I don't think they want us to do the push, or do they? In the create vote function, use the choice parameter and the message sender to create a new vote and push it in onto the array of votes. Perhaps we could just use the push method. We will do the choice. We'll pass in the choice from this parameter, and then the message.sender here. Let's try. Push not found visible. Okay, that's what I thought I was going to do. Perhaps what we could do is do the for loop where we loop through the votes, the vote at the message sender, push, and the choice. Let's try that. So say for uint I equals 0, I less than votes.length for the length of the array of votes being passed in. And that means at this point, one vote would be this. This would be one vote. But we want one vote where the message.sender is. So we'll do this. And I believe what we can do is say votes here at the choice. Let's try that. Message.sender is not convertible to this. Let's try. Store to the state variable. I'm surprised we can't just do the push deal here. Or push. Okay, let's take a look at what they've done. Oh, we could. The whole time. We could. We just needed to wrap it as a vote. Got it. So the data itself needs to be defined with the struct as well. So not only does the votes, how do I explain this? Not only does the vote just need to match like the data type, but the struct itself needs to be included to confirm this is the data type. I'm used to the TypeScript environment where this roughly would be fine to do. I suppose you could do const vote, something like this, or in this sense it would be uint vote. And I could say vote equals maybe this object, and then pass in the vote. Maybe this will work. Let's play around and break stuff. We'll pass it in as a tuple. Okay, looks like that won't work. You could see I like to break stuff, see how stuff works. I got to see a way that this will work real quick. So let's go to ChatGPT. Of course, I got to log in. We got to do the memory bit. Got it. Okay, that's important. So it's good to mess around and break things, right? Let's see, does that work? We're expanding the knowledge when we do this stuff. They're tiny things. You might say, what's the difference from this and this? And from a technical standpoint, there's none, right? They're both going to end up in the same result. However, it's important to understand, okay, if we start building out these huge objects, let's pretend our contract is much larger than a vote with just 2 bits of data. This might be something we need to do. We might need to chunk it out to data bits, because this might have a struct within a struct or something like that. You don't know how huge the vote might be. It could be uint timestamp. Okay, so then now we need to add a block time with this. It might need to be maybe there's an address who signs this signature, right? We could add more data, and more than likely by the time you get to a lot of data, you could have pretty big structs, in my experience of development. So with even this, with the timestamp, we would have to pass in the block.timestamp, but we might not be able to have access to all these things at the same time. Now, obviously in a smaller smart contract, this is a perfectly healthy way to do it here, it looks like. However, if we wanted to, let's pretend we don't have access to the timestamp for some reason, we might want to add things. Let's see if this is doable. I'm not sure if you could copy objects down in Solidity. Let's break stuff. Let's figure it out. Right? So we have vote, and technically this would be a partial. Unsure if they do partials on Solidity as well, so we'll see. But basically, I could copy down the vote object and then pass in the timestamp, and then push the vote. Let's see if ChatGPT can you make this work? I am trying to achieve a teaching point. Let's see. Okay, they just stashed the timestamp within the thing. Can you do partials in Solidity? Guys, I know this isn't part of the demo and whatnot, but it's important to understand these things. Looks like you can. Okay, so you just need to still initialize the timestamp, and then looks like we can add it later is how they have it. Okay, so that's good to know as well. Right? So this is what they've done. Timestamp equals 0, boom. And then down the road said vote.timestamp equals the block timestamp. Again, so they all end up on the same thing, but it's just important to understand the subtleties when constructing objects and data, because we are going to be doing a lot of that across time. So it's very important to understand how these things could look like, right? Let's change it back. So vote choice, and then of course the msg.sender, that global variable that we have access to at all times, and that should complete our challenge here. Okay, let's cruise through on choice lookup structs. Accessing struct properties, looks like we just do the dot method. So human dot name will allow us to do this. So if we do vote dot voter, we should have access to this. So your goal, create an external function to see who has voted. So has voted, which takes in an address, and I'll prepend the data with the underscore address, and it returns a Boolean value if someone has voted or not. Okay, do we need to find that function real quick? Create an external view function which takes in an address and returns a bool indicating if the address has casted a vote or not. Do we need to actually go through and do this? So for uint votes, or for uint I 0, I less than votes dot length, iterate through the votes. We'll say again votes at message.sender dot choice, I suppose. If that, I believe, is who we need to pass in into this find choice, then create an external view function find choice which takes in an address and returns choice's value indicating the choice on the vote cast by the address. For this function, there's no need to worry about a case where a vote was not casted. That's good to know. Okay, find choice, and we'll say external, forgot one bit here, returns a choice's value, indicating whether the choice on the vote was casted by an address. So I believe it'll return this. We'll need to muck around with that. Say underscore address here. Okay, so the first one, do we need to do that? Define whether they did vote or not. And this one, we need to define how they voted, right? I think that'll work for that one. Let's try that. See where we're broken here. So we have, excuse me. Oh, I see. Forgot a semicolon. Turns public. Okay, let's take a peek-see at what they've done. I think the second one we did okay. Yeah, the second one we did all right with. We did function find choice. We were almost there. Looks like find vote. Wait a moment. Find vote voter dot choice. I think what we've done on the second one will actually work. External returns choices. I'll leave the second one for now. I do believe that will actually work. External view returns choices. However, the first one, let's look again. What did they do? So they loop through to find the voter, return none if the vote has not done it. Okay, has voted, find voter, find vote, and oh, that's cheeky. Okay, so they have one vote function that they both point to that loops through, which returns one individual vote. How can they look at the address though? Oh, right here, boom. Here's how they search for the address and the votes. Right here, return votes, and that returns the one vote that equals their address. Okay, that's great. And the has voted, they just return the person who's voted. Okay, so we are almost there, actually. We are almost there. we could actually probably run with this. So basically they took out their for loop, put it in another function, and that's what they did there. So we could actually steal this bit, say return vote equals address, I believe. Let's see. Double equals. Let's see. Returns public. Ooh, I forgot a storage somewhere. Was it here? We're almost there though. So that's what they did. They took their for loop out of this, which is brilliant. But we just have 2 for loops. Not a big deal. Not a big deal. Okay. Vote storage returns a boolean, and this one returns choices. Public view returns boolean. Okay. Public view returns bool. What's the deal down here? Find choice, find choice. Okay. Find choice. External view returns choices. External view returns choices, right? Yeah. External view returns choices. Find choice address returns choices. We got you guys. Where am I going wrong here? What is this? Vote none. I think I need this bit right here. Return none. No. Okay. Let's take it to chat. What's this? Boom. Let's see. Return false. Okay. Let's take a look. See. That is what we needed. Okay, so 2 different approaches to it. One is this way, and then the other way is they abstracted the for loop out of it and did a find vote function. So let's do that real quick. Function find vote, which I believe takes in a vote. What does it return? Needs to return in a vote, right? It probably needs to find the address. Okay, so what this will do is if the votes at I equals we need the votes at I dot voter equals the address, return that vote, and that will effectively find the vote for us. So we can now take this double for loop out, and we just need to return find vote from this address dot what was the thing we were looking for? Not choice, but the other one, voter. And I believe right here it's going to be the same thing. But instead of find voter, we just say find choice. Let's try. Okay, ChatGPT, fix this. Here we go. Vote memory. Ooh, perfect. That's what we needed there. Okay, let's try that. Return vote voter. Got it. So this checks if it does the false case, but we don't need to check for that. Try this. Dot find vote. I think we can just do find vote. I feel like I'm missing something. Let's see. Return find vote voter. Okay, let's take a peek. So guys, I know it's irritated. Many of you probably clicked off by now. Oh, I see. Voter equals the voter. Okay, I forgot a little comparison. There we go. Right? Equals our address. We did address. Okay. But it's great to abstract on things and see, oh, there's different approaches, there's different angles, there's reasons why you might opt for one over the other. So a little bit of wrestling match there, but I'm going to wrap it up here. Thank you so much for joining the Structs deal. Let's see. We have single vote here. Maybe I can clean it up here. Or do I make it a second deal? Yeah, I'll make a second video. I think what I wanted to do is obviously get all the structs in one deal, but I would rather take things low and slow and really inch my way forward with knowledge and understanding. Okay, this is how you do this. This is why this one broke. This is why this one. You guys see me tinker with stuff all the time, and I think that same practice is what I'm trying to show you guys, because it looks redundant. It looks foolish. But by the time you feel out all the possible kind of, or at least a couple possible ways of how something looks and how do I explain what I'm trying to do? In my brain, this will make sense. I'll try to communicate it the best way possible, which is I'm feeling out an object in the dark with my brain is kind of what I'm doing, right? That's learning. Is you don't know the shape of how something is. It's your first time saying it, and you have to explore it in the dark. And your brain has to kind of like close its eyes and feel all the different nooks and crannies of the thing. You're like, okay, this thing is definitely an Oreo cookie. Like that's what I just felt. You know, I felt all the edges and the ridges. Okay, next thing, next piece of knowledge that I want to learn. Oh, this thing is definitely a wine glass. I closed my eyes and felt all the things and flicked it a bit, and I messed around with it. That's how I view learning is you're kind of, your brain's feeling something out in the dark. And that's why I take 4 different approaches, because it's like, okay, I need to just, if I just felt this coffee mug from just here, and if I had 0 visual indication of what it is, all these other things, is it a mug? Is it a Yeti cup? Is it a cup? Is it a glass? Like you need other things. So that's what I'm constantly doing. And I want to show that to you guys all the time. This is like what I'm doing now, is learning in public is hugely part of this channel because of the reason of, I think it's very effective. I really do. So I hope you stuck around this long. If you stuck around this long, good on you. And secondly, steal that. Learn by taking multiple approaches, and you will watch your knowledge have an exponential growth at the tail end of it. You'll have a gap in places, and you'll be like, how did I know to do that thing? It's because you know how the thing works robustly. I'll see you in the next one.